What's up, folks? Today we're going to be solving equations with fractional exponents. This is very similar to solving equations using reciprocal powers. In fact, in some ways you could just see these as more examples of that. The steps are slightly different though, in the way that I've worded them. But basically it's still going to be 5 simple steps in order to solve these problems. Let's review what reciprocal means. So here we have the numbers on the left. We have the reciprocals on the right. So for example, 1/2. The reciprocal is when you flip this to become 2 over 1. Simplify that to become 2, therefore the reciprocal of 1/2 is 2. -3/4, flip it, and it becomes -4/3. You don't change the sign for reciprocal. Now if it was the negative reciprocal, then you would change the sign. But for just straight reciprocal, you don't change the sign. And finally, if you flip 99, 99 is the same as 99 over 1. If you flip it, it becomes 1 over 99. So with that being said, let's do an example. We have x plus 2 to the 3/4 power minus 1 equals 7. So why is this an equation with a fractional exponent? Because it's an exponent that's a fraction. It's that simple. This is not an exponential equation, and that's because there's no variable in the exponent. So keep that in mind. As we go through these steps, they only apply to exponents. An equation that has an exponent that's a fraction, but the fraction doesn't have a variable in it. So anyway, step 1, move all the non-rational exponentials to one side. So let me be clear about what I mean by what is a rational exponential expression. It's the expression that has the exponent that's rational. So rational meaning can be written as a fraction. Basically what we're going to do is we're going to move everything that isn't that to the other side of the equation. So we're going to move this 1 over to the other side, meaning we're going to add it to both sides. And now we have x plus 2 to the 3/4 equals 8. So I know what you're thinking. Well, Mr. Underwood, you just said this wasn't an exponential equation. Well, okay, it kind of is. I guess what I really mean, it's not an exponential function. An exponential function has a variable in the exponent. Anyway, it's kind of one of those gray areas. It's not technically an exponential equation in the true sense of what an exponential function is, meaning a variable in the exponent. But it is an equation that has an exponential expression in it. So I don't want to confuse you too much with that. Anyway, that's the best way I could come up with how to explain this expression. It's an expression that has a fractional exponent. So in this step, we're moving anything that isn't that expression. So just this plain old 1, we're going to move it to the other side. And now we have x plus 2 to the 3/4 equals 8. Apologize for any confusion that may cause. Step 2, we're going to move the rational exponential expression, the expression with the fractional exponent, we're going to move it to the other side. Now normally once we move that one constant over or whatever, it's going to be isolated, meaning we'll have this expression on the left and our other expression on the right, the expression that isn't the fractional exponent. So why are we doing that? Well, that leads us to step 3. Going back to the reciprocal power thing, we're going to raise both sides of the equation to the reciprocal power of this expression. So let's be clear about that. What is this exponent? It's 3/4. So if we raise that to the 4/3, what will that ensure? Well, 3/4 times 4/3 is 1. So essentially it's going to cancel this fractional exponent. And since we do it to one side, we have to do it to the other. So we're going to also raise 8 to the 4/3. That's because 4/3 is the reciprocal of 3/4. Step 4, we're going to solve for the unknown. So how do we do that? Well, first of all, before we get x by itself, we can simplify 8 to the 4/3 by converting it to a radical expression. We know that 3, which is the bottom of the fraction, is going to become our root, and 4, which is the top, is our exponent. It's always going to be that way. So we have cube root of 8, which is 2. We're going to do that first, and then raise it to the 4th power. 2 times 2 times 2 times 2 is 16. Final step would be to subtract 2 from both sides, and voila, x equals 14. There is a 5th step, which is to plug that back in to make sure it's not an extraneous solution, meaning that when we plug that value in, the equation should equal itself, or equal out. So if we plug 16 back in and do some math, 4th root of 16 is 2, 2 cubed is 8, 8 minus 1 is 7, and it checks out. So x equals 14 is not an extraneous solution, and that is the answer to our first example. that's going to be it for this example. If you have any other questions about it, let me know.